Has anyone tried any of the question?
Yes, sir.
How many? Which question did you try?
Sir, solve the question of PKN.
First question means this one. The table.
No, sir.
Uh,
Solve the question of PKN.
Fourth question.
सर नहीं solved जो solved है.
That's a solved question. Oh, sorry.
Yes.
Sorry, I could not understand that. That you should read. Then only you will be able to attempt the unsolved problem. So that all of you should read, solve problems. And if you find any difficulty, then we can discuss those things. But here I want to solve the unsolved problems of the book at the end of the book. So we'll start with the first question. Let's see how many we can do today. The remaining will postpone for the further classes. But I want to do at least 50% of the question. I saw there are 32 questions. So my planning is to attempt at least 12 to 15 questions from this list. If you attempt some question and find some difficulty, then we can discuss those particular questions. And if you do not attempt question, if I have to attempt, then I'll select according to my understanding. I'll select few questions and leave the easier one. I think we should start with the first one. This should be minimized. I've just copy pasted the question here. It says complete the following. Is the screen visible?
Yes, sir.
Yes, sir.
Okay. Complete the following table of properties for 1 kg of water, liquid, vapor or mixture. So there are A, B, C, D, E, F, G, H, I, J, around 10 parts. 4, 5, 6, 7. The first one says give me a moment. Let me set my table, the tab, the pen. Should be horizontal. So where am I? This is the cursor. Okay. For the first part, we have given temperature as 35 degrees centigrade and volume of the mixture is given. Mixture means it's a steam and vapor or steam. We do not know actually whether it's a steam or vapor mix or it's superheated steam. So by comparing these properties from the steam table, we'll have to find out and then we'll look out for the other properties from the steam table. So let us go to the steam table and look out for the properties at 35 degrees centigrade. So we'll go to first saturated table and compare the volume at 35 degrees centigrade. So this is a table A1.1 at the end of the book. At 35 degrees centigrade, volume of the saturated liquid is this 0.001006 and saturated vapor is 25.216. Okay, what was the value here? 25.22. It's almost same. See, if this value would have been greater than 25.22, then it would have been superheated steam. If this value would have been less than 25.2, then it would have been a wet steam mixture of liquid and vapor. So for wet steam, we need to calculate dryness fraction, and with the help of dryness fraction, we'll compare the other properties. For superheated region, superheated steam, we'll have to see the superheated table, but this one seems to be the simplest question because the values is directly values given is for the saturated steam. We can just directly read these values from here. It's 25.22. I'm talking about values here. Yes, you can read it. So this is our part here. So from this table we have value of, okay, what has been asked? Internal energy, enthalpy. No, it's pressure. So we'll have to read the value of pressure. So this is saturated pressure and the value is where is the table? 5.628. Can we just minimize this? And minimize this on the left hand side. So it's 5.628 and it's kilopascal. So the pressure is 5.628 kilopascal. The dryness fraction should be 1 because it's saturated steam. So 1, or you can write 100%. X value is 100%. And there is no superheat. And the value of H is to be written. And the other value is S. So H should be, since it's at G point, so H should be at G. That means, oh, at G means this value 2565.3. So H is 2565.3 kilojoule per kg, and S is, see this, H is equal to Hg. S is also equal to Sg, and all these values are from saturated steam table A1.1. S is,
सर मैंने ग्रुप पे डाल दिया है PKN पे.
थैंक यू, 8.3530. ये वाली किताब है इंजीनियरिंग थर्मोडायनेमिक्स या अप्लाइड थर्मोडायनेमिक्स है?
सर इसी बुक से करने थे ना क्वेश्चन दो?
हाँ, क्वेश्चन एक्चुअली सेम है. पीकेएन की दो किताबें हैं थर्मोडायनेमिक्स की. एक है इंजीनियरिंग थर्मोडायनेमिक्स जिसमें आईसी इंजन और टरबाइन का पोर्शन नहीं है, और दूसरी है अप्लाइड थर्मोडायनेमिक्स जिसमें ये वाली किताब के अलावा कुछ चैप्टर एडिशनल है. आईसी इंजन, स्टीम टरबाइन, गैस टरबाइन भी है उस किताब में.
सर pdfdrive.net है वेबसाइट, और एक आपकी है bookoasia.com Z लाइब्रेरी. तो सर इन दोनों साइट्स पे आप अगर देखोगे आपको कोई भी बुक मिल जाएगी.
ओके,
सर मैं लिंक भेज दूंगा आपको, मेरे पास भी है सर, आप बोलोगे तो मैं डाल दूंगा. बस वो bookoasia पे ना थोड़े वायरसेस होते हैं.
अच्छा. नहीं, मैंने सर्च करने की कोशिश की, मुझे नहीं मिली. एनीवे, now since you have given the book, we'll make use of that. So this one was a simple question. Let's move to the part B. Part B is given value is 0.001044 volume and 419.04 enthalpy. The given volume is equal to 0.00, how many zeros? 001044. 1044. And enthalpy, which is meter cube per kg. And enthalpy value is 419.04 kilojoule per kg. Okay, let's move back to the steam table. We'll search for volume equal to this value from the steam table. So volume is this column. And the value is 0. How much? 0.001044. I think 0.001044. Is it 44? 1044 is standard value. 100 degrees centigrade. Just found this value. So that means enthalpy is 419.02 and entropy is 1.3068 and dryness fraction is 0. It's water. (419.02). So this value is at T is equal to 100 degrees centigrade. We found the value of fluid to be equal to the given value. So that means this is 419. Slightly different. 419.04 and this is 418.91. Let us check. 100 bar. 0.1 megapascal. This is with enthalpy. This is 417.44. 419.04. So we can use this value. It's atmospheric pressure, no? 101.3 bar is 101.35 kilopascal. So the pressure is 101.325 kilopascal. Enthalpy is given. Entropy is 1.3068. 3068 kilojoule kg Kelvin. And it's fluid, so dryness fraction is 0. So x is equal to 0. So these were simple problems. Let's move to the third part. It says temperature 212.42 and x 90. Temperature 212.42. Degree centigrade, and dryness fraction is 0.90. So we'll search this temperature value in our table. This is temperature based table, so we may not find directly 212, and we'll have to interpolate between 210 and 215. So we'll have to interpolate values here, but let's first check the pressure table also. So if it is saturated temperature at a fixed value of pressure in the table, then we may directly get that value. 212 is okay, 212.42. So this is the value. This is also direct value sort of from the steam table. This is at 2. What are these values? Megapascal. It's 2 megapascal. So pressure is 2 megapascal. And we'll have to use these values since the dryness fraction is given. So these values, this is at T is equal to 2 megapascal, and we can just read these values. इसको मिनिमाइज कर सकते हैं तो नीचे से yes, and this can occupy the other half of the screen. Oops, yes. So we are talking about these values. So I'm writing these values from the steam table. At 2 megapascal, saturation temperature is 212.42. Vf is 0.0011 meter cube per kg. Second is Vg. Let us write on this line itself. Vg is 0.09963 meter cube per kg. This is probably internal energy. Yeah? What is this column? Yes, these 3 columns are internal energy, and then 3 columns are enthalpy. So that means this is internal energy, not required. We need these values for enthalpy. So enthalpy HF is equal to 908.77 kilojoule kg. And either you can use Hg, or if Hfg is given, then we can directly use HFG. So the second column is HFG. It's difference between Hg and HF. So we write here HFG is equal to 1890.7 kilojoule per kg, and the third value is of entropy. SF is equal to 2.4473, and SFG is equal to this is SFG or SG. Second column is SFG. Fine, 2.4473 and 3.8935. $3.8935 kilojoule kg Kelvin. So we'll use our standard formula for wet steam, which is volume is equal to volume of the fluid plus X time VFG. Similarly, enthalpy is equal to enthalpy of fluid plus X time HFG, and entropy S is equal to entropy of the fluid plus change in entropy multiplied by the dryness fraction. So X into HFG. So if you do this, it should be 908.77 plus 0.9 into 1890.7. 908.77 plus 0.9 into 1890.7. This comes out to be 2610.4. 2610.4 kilojoule per kg. For entropy, it should be 2.4473 plus dryness fraction is 0.9 multiplied by SFG is 3.8935, and this comes out to be 2.4473 plus 0.9 into 3.8935. 3.8935. 3.8935. 5.9514. 5.9515. The unit should be kilojoule kg Kelvin. Is it okay?
Yes, sir.
We skipped something. We skipped the volume. So volume, you can use the same formula, but if you look at the values of Vf in comparison to Vg, there it's very less. It will start from the third figure after decimal. So if you are adding this to and it's not VG, it's not VFG, it's VG. So it should be 0.9 multiplied by, we want VFG here, so it should be VG minus VF, 0.09963. If you, sorry, minus 0.001177. Okay, now if you solve this, come out to be 0.09963 minus 0.001177. Yes, 0.001177. Yes, syntax error. क्या हो गया? 0.09963 minus 0.001177, 0.098453 multiplied by 0.9, 0.088 plus 0.001177, 0.001177. So it comes out to be 0.8978. 8978. I'm writing it 898 meter cube per kg. If we would have neglected Vg in comparison to Vf, then we could have written this as x into Vg. This would have given us 0.9 multiplied by 0.09963, and the value would have been then 0.9 multiplied by 0.9963, 89667, 0.89667 can be written as 7 and 3 significant figures. So this would have been the volume. It's 0.897. If you neglect Vf, this number is very small in comparison to Vg. Sorry. So what I am saying is that this number is very small as compared to Vg or Vfg. So you are subtracting this 0.001 from 0.09 and then multiplying it by 0.9 and then adding 0.001. So if you neglect Vf in comparison to Vg, then we can directly write V is equal to, say, either Vf, there can be two ways. Either you can write Vf plus x into Vg instead of Vfg. Then you will get a fairly accurate answer. But even if you neglect this Vf also, and you can directly write V is equal to x into Vg, you get this answer. And if you compare this answer and this answer, it's the error is of the order of 1% or 0.1%. 898 and 897, 1 in 1000. It's 0.1% error. So if if you are not want a very accurate answer, say the error of 0.1% or even 1% is acceptable, then you can directly write V is equal to x times, this is answer, this calculation will give you some result. This means X into Vg minus Vf. And the other calculation which I am talking about is X into directly Vg. So this give you more deviation as compared to the exact result. So this is while using exact formula, but if time does not permit, you can use this formula. And for gate examinations, when time is very critical, you should use this formula for calculation of V, because you have four alternatives. You do not want to find out the correct answer. You want to choose the correct answer. So if you can use this shortcut formula, then you'll be able to save time. This is applicable only for volume, calculation of volume. Don't use this for calculation of enthalpy and entropy. Although once you have done practice of lot of questions, then you will get a fairly rough idea of what should be these values that require large number of solving large number of questions. Okay, let us move to part D. Using. So part D is pressure given is 1 bar and entropy is 6.104. Now, pressure is 1 bar and entropy is, I forgot what was the value, 6.104. 6.104 kilojoule kg Kelvin. So we'll move to the saturated steam table, and since pressure is given, so we'll go to the pressure based table and read values from pressure based table corresponding to 1 bar. See, 1 bar is equivalent to 100 kilopascal. So 1 bar means multiplied by 100 kilopascal, and this is equal to 0.1 megapascal. So PKN book has table where the pressure values are not in terms of bar but in terms of kilopascal and megapascal. You might have steam tables where the pressure values are directly in bar. So we are looking for 100 kilopascal. हाँ जी.
सॉरी सर इंटरप्ट करने के लिए सर. फिर अभी क्लास ले नहीं पाऊंगा एक्चुअली. कुछ है अभी इमरजेंसी, तो दैट इज व्हाई आज की क्लास हो नहीं पाएगी.
क्या सभी लोग जा रहे हैं?
नहीं सर मैं अपना बता रहा हूँ.
Okay.
सॉरी सर. तो
No problem. I'll be solving questions till 9 p.m. If you are there, it's good. You can ask question if you wish. Even if you're not there, I'll just share this on MS Team and on this thing Moodle. So just go through those videos, and if you find any difficulty, you can ask me tomorrow.
Yes, sir. Thank you so much, sir.
Okay. So at 0.1 megapascal, the values are, we'll have to read these values. What all values we require? We have been asked about the temperature. So temperature is equal to saturation temperature. Now first we should make sure that the steam is wet. So entropy is 6.104. So if you just look at the entropy here, if the value is, this is entropy. So the value of the entropy given in the question is less than entropy of saturated steam corresponding to given pressure, that is 1 bar. So this tells us that the steam is wet. Steam is wet means we need to calculate dryness fraction. It's not superheated. If the value given in the problem would have been larger than the value of steam corresponding to SG value, that is 7.35, then we would have concluded that the steam is not wet, it is superheated steam. Then we'll have to switch over to the superheated steam table. But since entropy value given in the problem is less than entropy value of the dry steam corresponding to this pressure, so the steam is wet. So once you have determined what is the purity of steam, then we can solve for the dryness fraction of the steam. So the first thing which we should do is find out dryness fraction. If it is dry, calculate dryness fraction. If it is superheated, then calculate the degree of superheat. And how to find out dryness fraction? Dryness fraction can be calculated using any of the property. This time entropy is given in the problem, so we'll use the formula for entropy. Entropy given in the problem is 6.104. Entropy corresponding to this pressure in fluid state is 1.3025. This is SF corresponding to 0.1 megapascal. So this is 1.3025. 1.3025 plus X into SFG is SG minus SF. The value is given directly here in the table. This one is 6.0568. So X multiplied by 6.0568. So this will give us the value of dryness fraction. So X comes out to be 6.104. 6.104 minus 1.3025. The numerator is 4.8015 divided by, just to be divided by 6.0568. 6.0568. 0.7927. 0.7927. So X is 0.7927, or you can write it as 79.27% wet. Then what else? Then you should calculate the value of enthalpy and volume. So this can be calculated. I am directly using X into Vg, the shortcut formula. So 0.7927 multiplied by Vg is 1.6940. Sorry. This is Vg. 1.6940 So this gives us 0.7927. 0.7927 multiplied by 1.6940. 1.3428. I'm writing 4 digit after decimal. 1.3428. 3428 the universal meter cube per kg. For enthalpy, we should write enthalpy of the fluid plus X into change in enthalpy. So this is enthalpy of the fluid, and this is HFG. No, sorry. These are internal energies. Enthalpy of the fluid is this one, 417.44, and HFG is 2258.0. So this is equal to 417 point, what was the value? 417.44 plus 225. Sorry, should write here X first. X is 0.7927 multiplied by 2258. So this comes out to be 470.44 plus 0.7927 multiplied by 2258. Yes, 2258. 2207.3566. This is 2207.35. You can write here 36 kilojoule per kg. Now entropy, same formula or rather similar formula. X into SFG. SF is talking about 1 bar now. 1 bar. SFG is 1.3025. Zero 0.7927 multiplied by 6.0568. Oh, this is already given. S is already given. We need not calculate S. In fact, with the help of the value given for entropy, we have calculated dryness fraction. So that's over. So what we have done is we have calculated, we have read the temperature. This is D part. We have got the temperature, corresponding to 1 bar. This is 99.62 degrees centigrade. The value given here. So this is 99.62. Volume we have calculated. X we have calculated. This is not applicable here. H we have calculated. So that's all. So this completes our D part of this question. Let's move to the E part. Chapter 9. Chapter 9 is there are a lot of short examples, around 18 short problems. Okay, so now I have opened the book, so I want to look at the soft copy or the scanned copy which I send you. Don't require that now. We are at E part. E part, the given values are P is 10 bar, and T is 320 degrees centigrade. So what should we do? We should first find out whether the steam is wet or superheated. How do you find out that? Yes, is anyone listening? Hello.
Yes, sir.
Okay. So any suggestions for this question?
सर सुपर हीटेड स्टीम में है सर ये.
बहुत बढ़िया. कैसे पता चला आपको?
सर 10 डिग्री वो 10 बार पे सैचुरेटेड टेम्परेचर है 179.9.
That's good. So 10 bar corresponds to 1 megapascal. These values are in kilopascal. As you move, these are not in kilopascal. These are in megapascal. There seems to be a typing error. These are in megapascal. So 10 bar is 1 megapascal. So this is the value we are interested in. 79.91. So since temperature is much larger than the saturated temperature of the saturated steam, corresponding to 1 megapascal. So this gives us this conclusion that the steam is superheated. So we must move to the superheated steam table. Superheated steam table corresponding to 10 bar or 1 megapascal. So these tables are A 1.3, special 10 kilopascal, 50 kilopascal, 100 kilopascal. What we are looking at is 1 megapascal. So 1 megapascal is, this is 1.6. $800. I think these are the values. So corresponding to 10 bar is 0.19444. Yes. See the value of dry saturated steam is 0.1944. And this is the same value here. So I think one of the line has been missed here. So this is corresponding to 1 bar. Now at saturated state, that means at temperature 179.9, these are the values. Now for superheated steam, as temperature increased, the value changes. And we have been asked to find out values at 320 degrees centigrade. So we need to interpolate between these two values, 300 and 350. 320 is not directly available in the table. So we'll have to write these values and then we'll do the interpolation. Let's do that. So let us first find out the value of, we'll write all the values first and then we'll find out how should we write. We should write here volume and enthalpy and entropy and temperature equal to 300 degrees centigrade and temperature equal to 320 degrees centigrade. Sorry, 350. So 320 is required and 350 is known. So we know values corresponding to this temperature and corresponding to this temperature. And we have to find out values corresponding to a temperature which is midway between these two temperatures. So volume is, I think the first column is volume, internal energy, enthalpy and entropy. Okay. So volume is 2.2579, 4.2.2574, 0.25794 meter cube per kg, and the volume corresponding to 350 degrees centigrade is 0.28247. Let us write the value of enthalpy also. It's 3051.2. The units are kilojoule per kg, and this is 3157.7, and entropy is 7.1228, and this is 7.3010. So I have written these values, this one, this one, this one, this one, this one, and this one. Okay. So value of volume at 320 degrees centigrade should lie midway between the value of volume at 300 and 350 degrees centigrade. So if we assume that it changes linearly, that means if we draw a curve between, sorry, I wanted to make a straight line. Free state. So this is volume and this is temperature. So this temperature is 300, this temperature is 320, and this temperature is 350. So volume corresponding to 300 is known. This value is 0.2579. and volume corresponding to 350 is also known. This volume is equal to 0.28247. So we assume that the volume changes linearly as you move from 300 to 350. Then we can find out what is the volume corresponding to 320 degree. So this is to be find out. So what we'll do is we'll write volume at 320 degrees centigrade is equal to volume at 300 degrees centigrade plus change in volume, that is slope of this line. So change in volume is volume corresponding to 350 minus volume corresponding to 300 per unit temperature, that means 50. So this is the slope multiplied by 320 minus 300. Rate of change of volume with temperature multiplied by 20. So we'll write here 0.25794 plus 0.28247 minus 0.25794 divided by 50, and this whole thing multiplied by 20. So 2/5 of this entire change. So this difference represents change in the volume when when this steam temperature is changed from 300 to 350 degrees centigrade. So this change is for 50 unit, and we are interested in the change for 20 unit. So 2/5 of this change plus the initial value, that should give us the volume. So let us do this quick calculation. To 0.25 0.25794 plus calculator. Point 28247 minus 0.25794 is 0.02453 multiplied by 2 divided by 5. So this thing is to be multiplied by 2 and then divided by 5. It's 0.009812. This is 0.009812. So if you add this to 0.25794, we get 0.26775. 0.26775 meter cube per kg. Have you understood the interpolation?
Yes, sir.
Can you find out enthalpy at 320 degree centigrade?
सर मैंने पहले से ही फाइंड आउट कर रखी है.
वेरी गुड. कितना है वैल्यू?
सर इंथैल्पी की वैल्यू है 3094.66 किलो जूल पर किलोग्राम.
3094.66 किलो जूल पर केजी केल्विन. और एंट्रोपी की वैल्यू?
and entropy की value 7.1962.
So I assume that there is no calculation error and I am writing these values 7.1962.
1962.
Okay, kilojoule kg Kelvin. So the student can cross verify this. Now we'll move to the next part. Terminal new page F. So F is P is 5 bar and V is 0.4646. P is equal to 5 bar and V is 0.4646. Is it V now? 4646. Anybody has solved this question? If you have done the question, then I can directly write the answer and the others can cross check while they solve. If no one has solved, then I'll solve it. Okay, so I assume
No,
that
sir.
no one has solved it. So we'll again first of all find out whether the steam is wet or superheated. So we'll see the steam table corresponding to 5 bar. If the volume is given volume is greater than volume of gas corresponding to 5 bar, then we will conclude that the steam is superheated. And if this given volume, which is 0.4646, is less than volume of gas at 5 bar, then we will conclude that the steam is wet. In this case, we will try to find out degree of superheat, and if it comes out to be second case, then we'll find out dryness fraction. Of course, there can be a third case when the value exactly matches the value of steam at 5 bar. If this is the case, then we'll conclude that this is saturated steam. And in that case, we need not to find out any parameter for quality of the steam, and we can directly read the values corresponding to the saturated temperature. So let's go to the steam tables. 5 bar means 500 kilopascal.
सर सुपरहीटेड में यही है अभी.
Superheated है.
Yes, sir.
Okay. So what is the saturation and saturated temperature corresponding to 5 bar?
Sir, 151.8 degrees Celsius.
No, sorry. We should read the volume. Volume is given. No? So corresponding to 5 bar, what is the volume of gas? What is Vg?
0.37466.
0.37466. So this volume is greater than Vg. So that means this steam is superheated. This is an interesting question. Now we'll have to go to superheated steam table, and we should find out by how much temperature, by how much degree the steam has been superheated. So we'll go to steam table of superheated steam corresponding to 5 bar. 5 bar means 500 kilopascal. Okay. So these are steam tables corresponding to 500 kilopascal, and we are looking for a volume of 0.4646 meter cube. So this is volume 0.4249 0.4734 and 0.52. That means this steam has a temperature which is in between these two values, because our volume is 0.4, कितना था ये 0.4646. So 0.4646 lies somewhere here in between these two temperatures. So the temperature is more than 200, but it's less than 250. Let us write down this information. So if temperature is 200, then volume is 42492. So at 200 degrees centigrade, the volume is 0.42492 meter cube per kg, and at 250 degrees centigrade, the volume is 47436. I am leaving one space here. So at 250 degrees centigrade, the volume is 0.47436 meter cube per kg. So the task is to find out that temperature at which volume is 0.4646. So we have to find out this temperature. We'll use the same formula for interpolation. This time we know the value and we have to find out the temperature. So the value, which is 0.4646, should be equal to the initial value, that is value of volume at 200 degrees centigrade, which is this number 0.42492, plus 0.42492 plus the difference in the values 0.47436 minus 0.42492, and this difference is over a temperature range of 50 degrees centigrade. 250 minus 200. So I'll write here 50 multiplied by the temperature, which can be a number between 200 and 250, minus 200. So using this formula, we should be able to calculate the value of the temperature. Use and write here T minus 200 is equal to T minus 200 is equal to 0.4646 minus 0.42492 divided by 0.47436 minus 0. In fact, we should avoid numbers after three significant figure. 0.42492. 42492. We could have written it 0.465 minus 0.425. I think we should use this. Let us use only three significant figure, because we have a value after decimal point. So if we are using three significant figure, that means the probable chances of making an error is at the most 1%. So I am again writing this This is 4646. I am writing this as 0.465. 0.465 minus, I'm writing it 0.425. 0.425 divided by 0.474. 0.474 minus 0.425. 0.425. Okay, this minus this divided by this should be multiplied by 50. Multiplied by 50. So
Sir, 240 degrees Celsius.
240 degrees Celsius. Thank you. This comes out to be 240 degrees centigrade. I'm assuming your calculations are correct. So now what next? See, a degree of superheat is a term which is used to define quality of steam when steam is superheated. And this degree of superheat is by how much temperature the steam has been heated above saturation temperature. So saturation temperature corresponding to this given pressure, what is the pressure? 5 bar. We did not quote the temperature. It's 151.86. So if temperature would have been 151.86, then the steam would have been dry saturated. So it has been heated to 240 degrees centigrade above 151. Did I say 86? 151.86. So this difference is called degree of superheat. minus
88.14.
58.14. Thank you. 58.14 is the degree of superheat. So this should appear in this column in the question that has been asked about the, either you will write what is the inner fraction of the steam is wet, then you will write fill this column, and if it is not wet, if it is superheated, then you write this column. So here we should write 50, I forgot, 58 point.
88, sir.
58 point something. Okay.
Sunny, 88.
88.
Yes, sir.
88.
88.14.
88.14. It's 240 minus 151 ना, हाँ 88 हो सकता है. Sorry, I think I wrote incorrect here. So it's 88.14. So this value is 88.14. Okay. So next we should calculate enthalpy and entropy. So I'll quickly write the values of enthalpy at these two temperatures. 500 kilopascal. So we have temperature 200 and temperature 250. We'll write here values of enthalpy, and internal energy has not been asked, and entropy corresponding to these two values. So I think this third column should, this column should be enthalpy. 2855.4 2855.4 kilojoule per kg, and entropy 7.0592. 7.0592 kilojoule kg Kelvin. At 250 the value is 2855.4 के नीचे 2960.7. 2960.7, and this value is 7.2708. So the enthalpy of given steam should lie between these two values. थोड़ा सा बड़ा कर दें इसको, दोनों वैल्यू दिख जाएंगे. So enthalpy should be 2855.4 plus is at 240 degrees centigrade minus 200 degrees centigrade divided by this difference is for 50 degrees centigrade multiplied by 2960.7 minus 2855.4. So I've written the difference here this time. So if you quickly solve this, this is 240 minus 240, 4 by 5. This is 4 by 5 of this difference. 0.8 of this difference, 0.8 multiplied by 2960.7 minus 2855.4. It's 84.24, and this is to be added to 2855.4. 2855.4. 2939.64. So this enthalpy is 2939.64 kilojoule per kg. So I hope you can calculate entropy also like this, and I'm skipping that part. Or if you want to do, I can give you a few minutes. Just try to find out enthalpy so that we can write the final answer here, and then we'll move to the next part. It's already 9 o'clock. We have already written the values here. So 0.8 multiplied by the difference between these two values, and then add it to 7.0592. The calculation is not very lengthy. It's S is equal to 7.092 plus 0.8 multiplied by the difference, and the difference is 7.2708 and 7.0592. Seven point 2708 minus 7.0592 is 0.2116.
Sir, 7.2294.
That's good. I'm writing the values which you just said. 7.2294. Is this correct?
2294.
So you can cross check. So let's do another part. This was F. Let's move to G part. Journal, new page after. बैकग्राउंड में क्या आ गया है? This also I do not want. What is this? This is the file we are working on. So let's move to the G part, and G part says pressure is 4 bar and volume is 0.440. So pressure is
सर
हाँ जी
सर वो अब लीव कर सकते हैं, टाइम हो गया था.
हाँ hold back that. Okay, I think we should stop here and we'll continue this maybe tomorrow or day after tomorrow. Tomorrow I may not I'm not sure whether I'll be able to take the class or not. I'll inform you on the group. So we'll keep off on Sunday and then we'll continue from this point onward on Monday. So we'll few
Okay,
questions
sir.
we switch over to the next topic. Okay, you can leave. I am also leaving.
थैंक यू सर.
Okay. So this we'll do in next class. Hello, Madhav, are you there? Madhav?
So I'm just leaving.
Okay,
My
okay.